everyone. This is my presentation, Python Tips and Tricks, or how to simplify our daily job as programmers. At first, I want to thank Career Show and my company Hacksoft for providing me the opportunity to present this presentation to you today. Sadly, Career Show went fully online due to the coronavirus circumstances, but we all hope that everything will be back to normal soon and Career Show will be in place as it was before. So let's start with the presentation. A quick one about me. I'm a software developer at Hacksoft. We are a small IT company based in Sofia, Bulgaria, and we are the company behind one of the most big software conferences here on the Balkans called HackConf. You can see more information in our website hacksoft.io, or you can directly go to hackconf.com to see information about the conference. Apart from that, I'm an informatics student at New Bulgarian University, a second year now, and I'm using Python and Django on a daily basis to solve both my problems and the problems of our clients at Hacksoft. So let's begin with the Zen of Python. The Zen of Python is actually a list of 23 aphorisms which are actually representing the whole philosophy of Python as a language. If you open your Python console on your computer, and if you have Python installed, you can type import this. And by typing import this, the Zen of Python will be printed to your console. And it begins like this. Beautiful is better than ugly, explicit is better than implicit, and simple is better than complex. These are the first three aphorisms, and in my opinion, these are the most important ones, and the ones that if we use as a guide when writing our code as Python developers, we can keep our code cleaner, more readable, and more extendable in the future. So let's begin by showing you an example. We will start with a dict. This is a Python type, which is shortened from the English dictionary. You may have also seen it as hash map or dictionary in other programming languages, but in Python it is called dict. A dict looks like this. We have curly brackets, we have keys on the left side of the dictionary and values on the right side of the dictionary. So each key has a corresponding value. A note here is that each key needs to be unique for the given dictionary. The values do not matter here, but the keys need to be unique. And if you want to access a certain value of a given key, we can use the notation here on the seventh line. We can use my dict and use square brackets, provide the key that we want to get the value for, and we'll get the value. If we type another key, we'll get the other value. A note here is that if we type an invalid key, which does not exist in our dict here, we'll get an exception, but this is not the topic of the presentation today. So a question that pops up here is how we can actually check whether there are any items in the dict currently, if the dict is not empty. So we start with the methods of the dict that dict provides, and the first one is keys. If we use keys, we'll get the result, which is a list of the keys of our dictionary. So with our current example, with my dict, when we use keys, the keys methods, we'll get a list of key 1, key 2, and key 3, which are the keys provided here. If we have an empty dict, for example, we'll get an empty list because there aren't any keys in the dictionary. So if we use this, we can check whether the dict is not empty. So we can check if the length of my dict keys is more than 0, we can conclude that the dict is not empty. len here is a built-in Python function that returns the length of the given variable. In our case with keys, it is a list, and if it has any elements, for example, if it has 3 elements, which is our case here, we have 3 elements, 3 keys, len will return 3, and 3 is more than 0, so we can conclude that it is not empty. But with an empty dictionary, keys will return an empty list, and len will return 0, and 0 is not more than 0, so this will not be evaluated. As we have keys, we also have values. So values is the same method as keys, but it returns a list of the dictionary values here rather than the keys. And the same thing here, if you have an empty dict, values will be evaluated to an empty list because we do not have any values. So we can use the same notation. If the length of the values of our dict is more than 0, we can conclude that the dictionary is not empty, which is also a valid way of checking whether the dict is not empty. But we have a dictionary which looks like this, but if it's empty, it will look like this, just 2 curly brackets, opening and closing, and nothing between them. So we can, as length can be used with lists, it can also be used with dictionaries. So we can check if the length of my dict is more than 0, we can conclude that the dict is not empty, because whether we use keys or values, these are all valid, but keys and values will always have the same length, because we cannot have a value without a key and a key without a value. So we can directly check if the length of my dict is more than 0, we can conclude that the dict is not empty. And this is also a valid way of checking this. In Python, and not only in Python, in all programming languages, but in Python specifically, we have the bool type, which can be used in order to evaluate certain values to booleans, the so-called boolean evaluation. It is used like this. If we provide an integer value in this example to bool, we can get the boolean evaluation of this value. So in all programming languages and in computers at all, 0 is considered a false value and 1 is considered a true value. This is true for all programming languages that exist. But we can also provide another integer, and not only integers as we'll see in the next slides, to bool. So if we provide -42, we'll also get true. If we provide, for example, 101, we'll also get true. So everything different from 0 is considered, every integer, different from 0 is considered a true value. So we can use this in order to check whether our dict is not empty, because the if statement is actually evaluated to boolean, whether to check if it's true or false. So we can use if length of my dict is the so-called truthy value, we can conclude that the dict is not empty. There are the so-called truthy and falsy values, and len here is evaluated to an integer, and the whole if statement is evaluated to boolean after that. So we can use this check in order to see whether the dictionary is empty or not. And these are all valid examples of checking whether the dict is not empty, but as I mentioned, bool can be used to evaluate not only integers, but it can be used to evaluate different data structures. So with 0, we have false, but important thing here that is specific in Python is that we can also evaluate, for example, lists, as shown here, and an empty list will also be evaluated to false. An empty string will also be evaluated to false. But if we have an element in this list and the list is not empty, we'll get true, which is what we expect actually from bool to do. And if we have something in the string, we'll also get true and not false. And yes, you guessed it, this can be used with dictionaries too. So if we provide myDict to bool, if it is empty, it will be evaluated to false, but if it has any keys, elements in it, it will be evaluated to true. So we can just use if myDict as a statement, and if it is true, we'll print dict is not empty. And this is the most so-called Pythonic way of doing this, because as you can see, it looks more and more like a natural language. In this example, English, you just say if myDict has a truthy value, we can conclude that it is not empty. It has something in it. In this context, keys and values. The next example is with a list. I mentioned lists a few times in the previous slides. Lists are the so-called arrays in other programming languages. In Python, it's called list, and it's just a collection of items. And with dictionary, we accessed our elements by a specific keys that we provide. But in lists, these keys are called indices, and they always start from 0 and go up to the length of the given list. So with our case here, the first element of the list has an index of 0, and we can use myList square bracket 0, and we'll get the element with 0 index, which is the first element of the list. And the same goes with 1, 2, 3, and whatever the length of the list is. And the same thing happens here if you provide an index that is more than the length of our list. For example, if you provide myList 5, we do not have 5 elements here, we will get an exception, but this is, as I mentioned, not the topic of the presentation here. So another question that pops up here is how we can iterate over the list's elements along with their indices. So I want to iterate over the list and get 0 and A, 1 and 2, and 2 and none. So how we can do this? A very classic way of doing this in a lot of programming languages nowadays is by using a while loop. So we define an index variable here, which is equal to 0 in the first place, and then we perform a while loop while the index is less than the length of the list, and we print the index and the respective value with this index in the list, and then we increment the index by 1. So on the first iteration, we have 0 and A, which is correct. On the second one, we have 1 as an index and 2 as value, which is correct. And on the final iteration, we have 2 as index and none as value, which is all valid and can be used, but it's not that Pythonic, as I mentioned. Another way of doing this is by utilizing the range function in Python. What range does is that if you provide a one argument to range, and this argument is an integer, for example 3, we'll get all the previous integers starting from 0 to the provided integer here. So we'll get 0, 1, and 2. If you provide 5, we'll get 0, 1, 2, 3, 4, and etc. So we can use a for loop, which is also a common way of doing this in other programming languages, but there we don't have range, but it can be used with a for loop. We iterate over each index in the range of the length of my list. So length of my list with the example here will be 3. It will be evaluated to this array. And we iterate over each index. These are the indices here, over each index in the range, and we print the index itself and the value of this index in the list. So we again get 0 and A, 1 and 2, and 2 and none, which are the correct values here. So we achieve the same result, but with less code, and it's, in my opinion, more readable. But it's not the most that we can do here. What we can do actually is that we can utilize the Python enumerate function. What enumerate does is exactly what we want to achieve here. When a list is provided to enumerate, it returns an iterator, which I won't explain here what actually is, but if we use the same notation with the for loop, but here we iterate over a tuples of elements, here index and element, these are two elements on each iteration, from enumerate of my list, what we get is actually the first element of each iteration is the index itself, and the second one is the element. So we get the same result that we wanted to achieve, but with a lot less code. And as you can see, we do not actually access my list square brackets of index, but we get the element itself directly from enumerate. And thanks to this function, we can iterate over the indices and elements directly without any specifics by defining an index to 0 using a while loop and the things that I've shown you in the previous slides. And by using enumerate, this is the most readable and Pythonic way of achieving the task that we wanted to achieve, which is to iterate over the indices and the elements of the list and printing each other on each iteration. So this is the most simple and readable way of doing this. And as Dijkstra said, simplicity is a prerequisite for reliability. So if we tend to keep our code simple and readable, it will be a lot more reliable and extendable in the future. So make sure that you write your code in a simple Pythonic way, and this code will be a lot more extendable and usable, and it will live a lot longer when it is written in this way. With this, I'd like to thank you for the attention in the past few minutes. I hope that this was helpful. Again, I want to thank Career Show for the opportunity, and I hope everyone stays safe, be well, and to see each other in further editions of Career Show. Thank you. Also, I wanted to mention that we at Hacksoft are very keen on open source and on, especially on writing blog posts about some tech topics. And you can head to our GitHub profile. You can go to github.com/hacksoftware. This is our GitHub organization, and here you can see our open source projects, which are a lot. And especially what I wanted to show you is our most famous project, which is not actually a software product, but it's a style guide. This is our Django style guide. And this is just a huge paper of how we tend to structure and develop our Django projects. Because in Django, there are a lot of ways to accomplish certain things, and they all work. But when you try to develop a software product, you want it to be consistent, and especially you want to set boundaries. And what we try to accomplish here is to express our way of setting boundaries in Django, and we cover a lot of things here. We have sections for models, on how to structure them and write them. We have a section on services and selectors, which are things that we actually define as terminology in our Django projects. I'll not go into detail here, but you can check this in the style guide. We have section for APIs and serializers if you are using Django REST framework. We have section on URLs, on exception handling, on testing, which is very important. in our projects. We have section for salary and how to structure and develop your tasks. And mainly our inspiration, as I mentioned here, is the general idea for separation of concerns. We want to separate our logic into modules that are extendable, and when you transfer this project to another team at Hacksoft, the team knows how to continue developing it and also where things are situated. So if you're interested, you can head to hacksoftware-Django style guide. Give us a star if you want to, and if you like what we accomplished. And we develop this every single day. There are issues and pull requests that are opened often. So if you like it, you can give it a star. If you think something can be changed, you can open a pull request, and that's the main idea of open source. So I wanted to share it with you. And also, as I mentioned, we tend to write a lot of blog posts on some tech topics. So you can go to our website, which is hacksoft.io. This is our website, and in the upper right corner there is a blog button. When you click it, you'll be redirected to our blog section. We have a huge amount of blog posts. They are not only tech posts. There are, for example, the latest ones are posts for every member of our team. You can check these too. But if you go to the technology section here, you see our latest tech articles, which are a lot. And if you are developing with Django or React or Python and JavaScript in general, and if you stumble upon something, you can go here and check if something can help you. We also have articles for GitHub Actions, CI, Docker, a lot of things that are involved in the software development process. So you can go here and check if there's something you like, and we hope we can help you. That's it. That's how we think we can push the community forward, make it flourish, and just transfer our knowledge in public resources that can be used by everyone. And I hope we help a lot of people by doing this. Thank you.
Работа БГ. За всеки джоб.
Do you run awards, applications, call for papers, grants, scholarships, funding, or other programs? Aren't you sick of chaotic communication, hundreds of emails, and messy documents? This can be time-consuming and tedious at the very least. Say hi to Evolado, a next-gen submission and evaluation platform that streamlines all your work. No matter if you've got 10 or a bazillion submissions, we've got your back with the right tools. It's super simple and quick, Set up your program and tailor it to your needs in minutes. Then create a custom web page to collect submissions, or embed the form on your website, all fitting your brand's look and feel. Voila! Now applicants can start registering for your program. They get a personal profile to create, edit, and send their submissions with a click. And you manage submissions like never before, equipped with everything and more to make your job a breeze. The evaluation process is a walk in the park too. Customize it to your liking. Then invite judges and assign submissions to them at any time. Now the sweetest part. Monitor and analyze detailed statistics and grow your success. Did we mention Evoluto works with your favorite apps on the web? Yep, you can connect it to the tools and services you use every day. Evoluto is a joy for everyone involved. Applicants and judges will thank you for the convenient and quick system you've provided. And you and your team will enjoy the smart way to run programs, yet within your budget. Start working on your next program right away. No training needed. Sign up for free at evoluto.com.